Hello everyone, in this video we are going to learn about different sort of spectroscopic methods, their application, parts, the chemistry or principle behind them, all those related topics. So first let's learn what is microscopy. The interaction between electromagnetic radiation and matter forms the basis for spectroscopy. So the basic principle behind the phenomenon of spectroscopy is nothing else but the interaction between electromagnetic radiation and matter. When the electromagnetic radiation having a particular frequency is passed through a sample having a particular frequency is passed through a sample, the frequency which is absorbed or emitted by the molecules of the sample is determined at molecular energy level by analyzing the intensity of frequency emerging out of the sample. The instrument called spectrometer measures the change in intensity of electromagnetic radiation. Change. The results are interpreted in terms of stereochemistry of the molecule, three-dimensional spatial arrangements of atoms in a molecule. The spectrum obtained by the interaction in which a sample itself emits radiation is called emission spectrum. That is termed as emission spectrum. What is happening in case of emission spectrum? The spectrum obtained by the interaction which a sample itself emits radiation is called emission spectrum. The spectrum obtained by the interaction in which the sample absorbs radiation is called absorption spectrum. Absorption spectrum. When atoms absorb electromagnetic radiation, their electronic energy is increased, resulting in a spectrum in the form of spectral lines of varying wavelength. This is called atomic absorption. Atomic absorption. The spectrum obtained by the interaction in which a sample itself emits radiation is called emission spectrum. The spectrum obtained by the interaction in which a sample absorbs radiation is called absorption spectrum. When atoms absorb electromagnetic radiation, their electromagnetic energy is increased, resulting in a spectrum in the form of spectral lines of varying wavelength. This is called atomic absorption. On absorption of electromagnetic radiation, the molecules become excited. When the molecules return to their original ground state, they emit molecular spectrum in the form of bands, each line of which is composed of a large number of very fine lines. This process is called molecular absorption. The energy associated with the uniform motion of molecules is called translational energy. A molecule also possesses some forms of internal energy, including rotational energy, which is due to the overall rotation of the molecules, vibrational energy, which is associated with the oscillation of atoms of the molecule, and the electric or electronic energy, which are the three types of energies associated with the molecule. Rotational energy will be there, vibrational energy will be there, and the electronic energy will be associated with that, which is due to the movement of electrons. In a movement, the levels of rotational energy are closely spaced so that very little energy is required for rotational transitions. This occurs in the infrared and microwave ranges of the electromagnetic spectrum. So, infrared and microwave region is responsible for rotational energy. Okay. And this is useful in the study of molecular structure. The vibrational energy levels are spaced apart and occur in the infrared region of the spectrum. When molecules absorb photons of electronegative radiation in the visible and ultraviolet regions, the electronic energy is increased, causing rotational and vibrational changes. As a result, the molecular spectrum exhibits bands of wavelength, which are represented by lines. Now, ultraviolet and visible spectroscopy. We are dealing with the ultraviolet and visible spectroscopy. When electrons in an atom are excited, radiations are absorbed, resulting in the absorption spectrum of the atom. Similarly, when the electrons of a molecule are excited, the electronic spectrum originates due to change in the arrangement of molecular electrons. The electronic spectra of molecules occur in the visible and ultraviolet regions of electromagnetic radiation. A small change in electronic energy results in a large change in vibrational energy, which in turn results in a change in rotational energy of the molecule. In other words, the molecular electronic spectra involves change in electronic, vibrational, and rotational energy of the molecule. The UV absorption spectra are due to the transition state of an electron or electrons within a molecule or due to an atom, which occurs from a lower to higher electronic energy level. The UV emission spectra are due to the reversion of transition. UV emission spectra are due to the reversion of transition. The ultraviolet spectrometer consists of the following components. First, we will be needing a radiation source. First component needed is a radiation source. Radiation source is needed. The source of radiation may be hydrogen discharge lamps, deuterium lamps, xenon discharge lamps, or mercury arcs. The source of radiation. We need a source of radiation. So that source of radiation can be a hydrogen discharge lamp. Hydrogen discharge lamp can just emit radiation. Hydrogen discharge lamps, deuterium lamps, xenon discharge lamps, or mercury arc. Never forget the last one, that is the mercury arcs. Xenon discharge lamps. The source of radiation may be hydrogen discharge lamps, deuterium lamps, xenon discharge lamps, or mercury arcs. Which are they? Hydrogen discharge lamps, deuterium lamps, xenon discharge lamps, or mercury arcs. In all these lamps, the electrons are passed through a gas so that electronic, vibrational, and rotational excitations are produced in gas molecules. Next, we need monochromators. These are dispersion elements which may be prisms or gratings made up of glass, quartz, or fused silica. The monochromator disperses radiation based on the wavelength. First, we will be needing a radiation source. Then we need a monochromator. Next, we need detector. What are monochromators? These are the dispersion elements which may be prisms or gratings made up of glass, quartz, or fused silica. The monochromator disperses radiation based on the wavelength. Next, we will be dealing with the detectors. We need detectors. These major types of detectors are used, namely photovoltaic cell, photocell, and photomultiplier tube. Photomultiplier tube. Just never forget the detector term. Detectors are used to detect this. So photovoltaic cell, photocell, and photomultiplier tube are associated with this. Then photovoltaic cell, it consists of a semiconductor selenium plate tightly fixed on a strong iron base. What is the photovoltaic cell? It consists of a semiconductor selenium plate tightly fixed on a strong iron base. The plate is coated with a thin layer of silver or gold so that it acts as an electrode. When radiation falls on the surface of the plate, electrons are produced at the selenium-silver interface and are accumulated on its silver surface. This produces electrical voltage which is proportional to the intensity of the incident radiation. So, we have learned that detectors are necessary. So, when we just explain the term of one of the detectors, that is photovoltaic cell, that consists of a semiconductor selenium plate tightly fixed on a strong iron base. The plate is coated with a thin layer of silver or gold so that it acts as an electrode. When radiation falls on the surface of this plate, which acts as a detector, electrons are produced at the selenium-silver interface and are accumulated on its silver surface. This produces electrical voltage which is proportional to the intensity of the incident radiation. So that detects the incident radiation. Okay. So selenium plate will be there and iron base will be there. photovoltaic cell can be easily drawn by just drawing a rectangle. Photocell, next type of detector was a photocell, which we have mentioned earlier. So that photocell, it has a light sensitive material. Light sensitive material is there. Light sensitive material, and that's a metal. Light sensitive material is a metal, and that forms a cathode and an anode placed inside an evacuated glass tube. We are talking about photocell. So there will be a cathode which is made up of high light sensitive metal. Anode is also there, which is it is both type of electrodes, cathode and anode, are placed in evacuated glass tube. The inner surface of the tube is coated with light sensitive substance. When we draw the structure of this photocell, you will be drawing a rectangle. In that there is a cathode will be there, a glass tube, evacuated glass tube will be there, which is coated with light sensitive substance. Light sensitive substance. Okay, and along with that, anode will be there. So this cathode and the anode is situated inside a evacuated glass tube. Evacuated nothing else, it's nothing else but just a type of detector, photocell. Okay, next, light falls on the surface coating. Electrons are emitted and are collected by the anode. The resulting current is equal to the intensity of radiation. This photodetector is also used for detecting the radiation incident. Light falls on the surface coating, electrons are emitted and are collected by the anode. The resulting current is equal to the intensity of the radiation. These electrons are collected by anode. Anode is something which collects these electrons. Electrons. Now the third one is the photomultiplier tube. This is also a type of detector. Photovoltaic cell, photocell, and then third one was the photomultiplier tube. It has an evacuated tube containing one metallic cathode and anode with many diodes. When radiation falls on the cathode, the electrons are emitted and attracted by successive diodes with the emission of more electrons at each diode. As a result, the large number of electrons are produced and are proportional to the intensity of the falling radiation. So there are some structures associated with this photomultiplier tube, that is nothing else but the diodes. Diodes are the structures which just transmit the light ray, reflect back that. So diodes will be there. Light ray is hitting on them and just returning back. Cathode is there, anode is there. What is happening in a photomultiplier tube? It has an evacuated tube containing one metallic cathode and anode with many diodes. When radiation falls on the cathode, the electrons are emitted and attracted by successive diodes with the emissions of more electrons at each diode. As a result, a large number of electrons are produced and are proportional to the intensity of the falling radiation. So greater the amount of radiation falling on this particular detector, greater is the emission of electrons, or that is easily emitted as a current. Next part of a spectroscope is nothing else but the recorder to record the result. It receives the signal from the detectors and records the results. What are the uses of these spectroscopes? Visible and UV spectroscopy are useful in determining the concentration of biological substances. Used to detect the concentration of biological substances. Here we have learned about three types of detectors. First one was the photomultiplier. Next, photocell was there. Next is the photovoltaic cell. These three types are detectors to detect the incident radiation and showing off that incident radiation as a current. So recorder records all this information. So which are the major parts associated with this? First we need a radiation source, then monochromator is needed, then photomultiplier tube. along with various salt detectors and a recorder. Visible and UV spectroscopy are useful in determining the concentration of biological substances, as the basis of the nucleic acid absorb UV rays. UV spectroscopy is used to study denaturation of DNA double helix. It is also employed to characterize aromatic compounds, to detect impurities in organic substances, determine molecular weight of many compounds, and dissociation constant of acids and bases measuring, study kinetics of reactions. These are the major applications. Which are the concentration, to know the concentration of biological substances, to study about the denaturation of DNA, and then the characterization of aromatic compounds, to detect impurities in organic substance, determine molecular weight of many compounds, to know the dissociation constant of acids and bases, and study kinetics of reactions. Next is the mass spectroscopy. Mass spectroscopy helps to separate atoms or molecules in a compound on the basis of difference in their masses. When a compound is bombarded with beams of electrons and ionic molecules are produced. Thus, molecules separate according to their masses and produce a spectrum called a mass spectrum. Diagrammatic representation of a typical mass spectrometer. We can just see that a sample is there, then a system, internal system will be there, ionization chamber and accelerator system. Along that, an analyzer and the ion collector will be there, and reorder will be happening. In this mass spectrometer, an inlet system is needed. Inlet system. As the instrument requires a vaporized sample, the sample is converted into vapor in the inlet system by heating. As the instrument requires a vaporized sample, a sample is converted into vapor in the inlet system by heating. The volatile sample is heated in a flask and introduced into the ionization chamber. If the sample is a gas, it is transferred from a gas bulb through melting and expansion reservoirs. Liquid samples are then injected by hydrothermic needle through silicon rubber tube. So after that, inlet system contains all these materials and produces the volatile vapors of this respective sample, and then ionization chamber will be there. Ionization is happening. Ionization chamber is the must needed part of this system. This provides the source of ions. Here a beam of electrons is passed through the molecules of the sample so that the molecules become ionized. Here is a variety of methods for ionization of the samples, and it as follows. Electron impact ion source. This is used in most of the instruments in which an electrically heated filament produces electrons which are accelerated by the anode. This beam of electrodes intersects with sample molecules, resulting in positively charged molecules in the form of mass spectrum. First, we will be transforming the sample into volatile vapors. After that process is happening inside an inlet system. After that, ionization is happening inside of the ionization chamber. Later, for that ionization purpose, we have electron impact ion source, which is used in most of the instruments in which an electronically heated filament produces electrons which are accelerated by the anode. Thus, a beam of electrons intersects the sample molecule, resulting in positively charged molecules in the form of mass spectrum. Next, we need condensation cell. Here, the sample in a cubicle is vaporized through heating by radiation or by electron bombardment and is directed towards the analyzer through a small hole. Spark source ionization is also another method of ionization. Spark source method. By this method, The sample is made into 2 electrodes to which high voltage is applied. As a result, positive ions are produced and are evaporated. Surface ionization. In this method, the solid sample is coated on a filament of ribbon and heated. Now the positive ions are evaporated. These are the various methods of ionization. So first is the electron impact ion source. Electron impact ion source. What is happening in the electron impact ion source? Electrically heated filament produces electrons. That's it. Next, in the second type is the condensate cell. Sample is vaporized through heating by radiation or by electron bombardment. Next is the spark source ionization. Here, 2 electrodes are present and in which high voltage is applied. As a result, positive ions are produced and are evaporated. Then surface ionization. Solid sample is coated on a filament of ribbon and heated. Now the positive ions evaporate. Next, chemical ionization is also another method. Here, gas like methane is introduced along the sample under a beam of electrons so that the gas ionizes and interacts with the sample molecules to form positive ions. So we need positive ions. And accelerator system is there. It includes electric fields which receive the positive ions from the vaporization chamber and accelerate the electrons according to their masses. The accelerated ions are passed on to the analyzer through a slit. Next, analyzer ion separator. It is the most important component of the instrument and it separates the ions according to their masses. Accelerator system accelerates the ions according to their masses. Next, analyzer ion separator is also needed. This is the most important component in the instrument as it separates the ions according to their masses. Based on the nature of analyzer, various types of mass spectrometers are designed. Ion collector is also there. Ion collector. This includes photographic plates, electric multipliers or electrometers. A photographic plate provides great resolution and sensitivity and so it is more advantageous. Next, vacuum system is needed. The entire instrument is kept in a vacuum tight chamber. Mass spectrometry is used to determine molecular weight of substances, quantity of isotopes in vaporizable elements, ionization potentials of molecules and bonding nature of macromolecules. First one is the nuclear magnetic resonance NMR spectroscopy. Radio waves are electromagnetic radiation with the lowest energy and induced transition in magnetic level of the nuclei of atoms. Though the energy in radio frequency is very small, it affects the nuclear spin of atoms in a molecule so that the nucleus of an atom changes the direction of its spin on absorbing radio frequency radiation. When nucleus absorbs energy, it becomes excited and loses energy in return to an unexcited state. This nucleus with alternate excited and unexcited conditions is said to be in a state of resonance. The absorption of radiation in the radio wave region of the electromagnetic spectrum by the nucleus in a specific magnetic field and its change from low energy state to high energy is called nuclear resonance. The nucleus with alternate excited and unexcited conditions is said to be in a state of resonance. The absorption of radiation in the microwave region of the electromagnetic spectrum by the nucleus in a magnetic field and its change from low energy state to high energy is called nuclear resonance. The energy absorbed by the nucleus is measured to determine the resonance frequency. When a nucleus absorbs energy, it produces a signal which is detected, amplified and recorded as a band of spectrum called NMR spectrum. The important components of NMR. The energy absorbed by the nucleus is measured to determine the resonance frequency. When the nucleus absorbs energy, it produces a signal which is detected, amplified and recorded as a band of spectrum called NMR spectrum. The important components of NMR spectrometer are diagrammatically represented. The illustration contains the following parts like a transmitter, RE receiver, detector and amplifier along with the recorder, sample holder will be there, radio frequency generator and a magnet, and a sweep generator will also be there. So sample holder. Glass tubes are generally used as they are chemically inert, durable and transparent to radio frequency changes. Next, a magnet. Permanent magnet or electromagnet is used. The magnet provides a homogeneous magnetic field and strength of which should be very high and constant. Sweep generator. Sweep generator will be there. It has a pair of Helmholtz coils fixed in the pole space of the magnet. These coils produce magnetic field which can be changed by varying current flow. Thus, it brings varying applied magnetic field to bring nuclear resonance. The magnetic field from these coils are added to the main field so that the sample is exposed to both magnetic fields. Therefore, the sample becomes magnetized. Sweep generator is a pair of Helmholtz coils fixed in the pole spaces of the magnet. These coils produce magnetic field which can be changed by varying current flow. Thus, it brings varying applied magnetic field to bring nuclear resonance. The magnetic field from these coils is added onto the main field so that the sample is exposed to both magnetic fields. Therefore, the sample becomes magnetized. That's happening in case of sweep generator. So, which are the parts? Transmitter, RE receiver, detector and amplifier along with the recorder, sample holder will be there, and radio frequency generator along with magnet and sweep generator. Next, radio frequency generator. A radio frequency oscillator produces radio frequency radiation. A radio frequency generator. A radio frequency oscillator produces radio frequency radiation. The coil of oscillator is wound around the sample holder in order to irradiate the sample with radio frequency radiation. Next, radio frequency receiver. In the magnetized sample, the frequency undergoes absorption and dispersion. The receiver determines the resonance frequency which is directed to the detector. Detector and amplifier will be there. A phase sensitive detector separates the absorption signals from dispersion signals. As the absorption signal from the receiver is extremely weak, the amplifier amplifies it. Recorder. A chart recorder records the amplified signal. NMR spectrum of the sample is obtained by plotting the intensity of the signal against the strength of the magnetic field. By using this technique, a three-dimensional structure of small protein molecules can be determined. It is also useful to study the dynamics of protein molecules and small conformational changes, intracellular pH, membrane transport, and concentration of metabolites in tissues and organs. The NMR spectrum of sample is obtained by plotting the intensity of signal against the strength of the magnetic field. By using this technique, the three-dimensional structure of small protein molecules can be determined. It is also useful to study the dynamics of protein molecules and small conformational changes, intracellular pH, membrane transport, and concentration of metabolites in tissues and organs. Next one is the electron spin resonance. The absorption of radiations of a specific frequency by the electrons under a magnetic field and their change from low energy state to high energy state is called electron spin resonance. The two states of energy levels are produced by the interaction between the magnetic moment of the unpaired electron and applied magnetic field. Substances with unpaired electrons absorb radiation having the frequency of the microwave region. The electrons produce transitions between magnetic energy level resulting in ESR spectrum, which is measured by plotting the intensity of the signal obtained by the spectroscopy against the strength of the magnetic field. The electron spin resonance spectroscopy is more or less similar to nuclear magnetic resonance spectroscope, but the sensitivity of ESR spectroscope is comparatively higher than NMR spectroscope, and it requires only very little quantity of the sample. The important components of ESR spectrometer are shown in the figure. It consists of a power supply, klystron oscillator, isolator and wave meter, along with the attenuator, circulator, detector, amplifier, oscilloscope, automatic reader, magnet and sample, along with power supply and sweep unit. Characteristics of this ESR, electron spin resonance spectrometer. Source of microwave radiation, klystron oscillator. The klystron oscillator is a vacuum tube which produces microwave radiations on applying voltage. An isolator minimizes the vibrations in the frequency of microwaves. The frequency of microwaves is known from a wave meter. The microwaves are transmitted to a circulator by an attenuator. Circulator is a hollow rectangular tube formed by copper or brass with silver or gold plating to have a high conducting flat surface. The microwave radiations are passed towards the sample from one end of the circulator and the end is attached to the detector. Circulator is a hollow rectangular tube formed by copper or brass with silver or gold plating to have a high conducting flat surface. The microwave radiations are passed towards the sample from one end of the circular and the other end attached to the detector. So these are the parts: power supplies needle, klystron oscillator, isolator, attenuator, circulator, detector, amplifier and oscilloscope, automatic reader and sample, power supply, magnet and sweep unit. Next is the sample cavity and magnet system. Flat cells are used as sample holders. The sample holders are placed on the sample cavity in which maximum magnetic field is maintained throughout the sample. The sample cavity is placed on the electromagnet which provides a uniform magnetic field. A pair of sweep coils are provided for varying the power supply. Detector. A silicon crystal detector is mostly used. It converts the microwave to electrical current which is amplified in the form of a narrow band. Recorder is also there. The signal from the amplifier is recorded by an oscilloscope or by a automatic recorder. They are spin labeled and are used in ESR spectroscopy. In this way, the technique is used to determine the rate of enzyme reactions, to find substrate binding regions of enzymes, to study denaturation and folding of protein molecules, enzyme linked interactions, and symmetry and orientation of protein molecules. The apparatus is also used to study free radicals and inorganic compounds.